Here I want to establish what a zero of a function is, as well as how we can determine a zero of a function. So what a zero of a function is it is the input value or values that make the function's value equal 0. So really breaking that apart, a zero of a function is exactly what you're actually able to plug into the function to make the output actually equal the number 0. So in a context of like a relationship between x and y, right, then a 0 would be the x value or the x values that you can plug in that's going to make your y output become 0. So taking a look at some examples, we're asked to find the zeros of each function, which means you want to find what's going to make y equal to 0. So if I have this equation y equals 2x minus 8 and I want to find the 0 of this function, then I want y to be 0, which means I should plug in a 0 for the y, and then I should be able to solve this equation here for the x or x's that is going to make the y become 0. And so if we do solve this equation by adding 8 to both sides and then dividing by 2, what we end up getting is that we end up getting that x equals 4 is the 0 of this function, and we can just verify and check to make sure that that actually works, because if you do put in 4 for x into the 2x minus 8, then y does equal 0, right, when we plug in 4 for x. So that does turn out to be the 0 of the function. And this really works nicely graphically to see how this all relates, right? And when you think about if we want y to be 0, and you think about on a graph where y would be 0, that's going to be on the x-axis, right? Because you're at a height of 0. And so whenever we deal with zeros of functions, at least the ones that are real zeros, you're going to see that they're actually going to correspond to the x-intercepts of the graph of the function. And you can verify that that graph right there is indeed the line 2x minus 8, since it has the y-intercept at negative 8 and then a slope of a positive 2 right there. So right here we've got the function f that we want to find the zeros of, which means that we want to substitute in a 0 for the output f of x right there, and then be able to solve for the x or x's that is going to make this work. And now this is quadratic, right? And so we might want to try to factor, and it's pretty slick to be able to factor that right-hand side, because it's going to be x plus 2 times x minus 2 to factor that difference of squares. And because it's equal to 0, we can use the zero product property to conclude that either x plus 2 then has to be 0, or that x minus 2 has to be 0, which then gives you negative 2 or positive 2 as solutions for x. And those indeed are going to be the zeros of the function, because if you think about it, right, what's going to happen if you plugged in negative 2 for x? You'd get 4 minus 4 to 0, and then what would happen if you plugged in 2 for x there? You'd get a 0 for your y as well. It does turn out that this parabola right here is the graph of f, the equation x squared minus 4 is equal to f of x, and then you can see that right there are the two x-intercepts, so that'll give you the real zeros of the function there. So g and h are also just quadratic functions. Really, it's just kind of a matter of, factoring. So if we do factor this right-hand side, once we've plugged in a 0 for y, it does factor to get negative 12, but add to 1, I think you need a plus 4 and then a minus 3. So if x plus 4 equaled 0, then you'd get a solution of negative 4, and then if x minus 3 equals 0, you'd get a solution of positive 3. And so those end up being the actual numbers that you can plug in for x under the function g to give you a 0 output, and you'll see that that definitely corresponds with the x-intercept right there of negative 4 and 3. And then for the function h, to find the zeros of the function h, we'll have to plug in a 0, and then 0 is going to be equal to negative 2x squared minus x plus 3. So since this is quadratic, if we want to factor that right-hand side, you'll note that there's that negative leading coefficient. So you're going to want to start by, first of all, making your life a lot easier and factoring out a negative, so that you're going to get then plus x, but then minus 3 now once you factor out that negative. And then we can concern ourselves with this quadratic factor right there and try to factor that just a little bit further. So we've got negative 1 that times is with, so since it's 2x squared, it's going to have to be 2x times x. And then the last numbers are 3, which we're going to get by 3 and 1. I think you're going to have to put the 1 here, because you're going to get 2x there, and then if you put the 3 there, you can get 3x there, and you can make it add to 1x if you add 3x but subtract 2x. So you're going to have to make that plus and make that minus, therefore, to get that factored correctly. All right, so then based on that, that's not going to help us solve for x, as it doesn't have an x. But then using the zero product property, if 2x plus 3 equals 0, that leads you to negative 3/2 when you solve as a solution. And then if that equals 0, that leads you to a positive 1. So it does turn out that negative 3/2 and positive 1 are the zeros of that function. You can verify that also by looking at where the x-intercepts are going to land on that particular graph. And then just emphasizing the fact that you can use the graphs of functions to be able to find its zeros. Now, I should have been a little bit more specific, because when we get into zeros later on, sometimes we might talk about zeros that aren't necessarily real zeros or real number zeros. So if you're going to use a graph to find zeros, really you're only going to be able to find the real zeros. So if you're looking for a zero of a function, by definition, you want the y value to be 0, which you can find the real zeros if you look for x-intercepts. So if it does just like touch the x-axis, that is a place where y would be 0. So right there would be like at the number -4. So x equals -4 is a 0 of that particular function. For the parabola in the middle right there, you can see it's crossing through -1 as well as 3. So that means that -1 and 3 as x values are going to be zeros of the function. And again, with all these guys, right, like you can plug in those numbers into the equation for x, and then you'll see that you'll get an output of 0 for y. And then for this right here, you can see that it has no x-intercepts. And so it seems like, okay, how in the world am I going to get, y to be 0? So it turns out that there are no real number zeros, because it doesn't cross through the x-axis. It does turn out that there are actually zeros of the function, and we'll understand that kind of more later on. But just for right now, if it doesn't cross through the x-axis, then we know at least it doesn't have any real zeros.